So for part A, from equation 4.177, we know that 1 is equal to 1 under root 2 plus, and the lowering operator if s negative is equal to s negative 1 plus s negative 2, and therefore we can write that s negative 0 1 is equal to s negative 1 plus s negative 2 1 over under root 2 plus, so when we'll solve it, we'll get that it is equal to 1 over under root 2. Over here we have s negative 1 plus s negative 2 downward upward plus downward upward. And when we'll multiply it, when we'll open the parenthesis, we'll get that it is equal to 1 over under root 2 s negative 1 plus s negative 1 plus s negative 2 plus s negative 2. And over here, if you notice that s negative 1 can only act on the first particle, the first arrow, and the s negative 2 can only act on the second particle, that is the second arrow. So from here we conclude that s negative 1 is equal to 1 over under root 2 h plus, so when we'll solve it, we'll get that it is equal to this, and over here this is equal to 1 negative 1, and thus we can write it as s negative 1 under root 2 h 1 negative 1. So for part B, we know that s positive negative is equal to s positive negative 1 plus s positive negative 2. And from equation 4.178, we have 0 is equal to 1 over under root 2 negative. So let us start with s positive 0 and let's look at how it will go about. So over here we have s positive 1 plus s positive 2. Over here we have 1 over under root 2, upward, downward, negative, upward, and this is equal to 1 over under root 2 s positive 1, downward, upward, s positive 1, downward, upward, plus s positive 2, downward, negative. I'm writing out of space over here, so I'm going to write it over here. 2, downward, upward. And when we'll solve it, we'll get that it is equal to 1 over under root 2 s positive 1 negative s positive 1 parenthesis plus s positive 2 parenthesis s positive 2, and over here you can see that s positive 1 is equal to s positive 2, that is equal to 0 because we cannot raise the higher possible state, and s positive 1 is equal to s positive 2, that is equal to this. So by using this we get that s positive is equal to 1 over under root 2 negative h, and this is equal to 0 because these two terms will cancel out and anything multiplied with 0 is 0. So from here we conclude that s plus 0 0 is equal to 0. Next we will work for s negative 0 0. We'll solve it just like we did the above one, and we'll get that it is also equal to 0. Next we for c part, first we define the operator s square for two combined states, that is s square is equal to s1 plus s2 times s1 plus s2, that is equal to s1 square plus s2 square plus 2s1 times s2. So over here we have this term s1 s2 is equal to sx1 sx2 plus sy1 sy2 plus sz1 z1 plus sz2, and we can show that s211 is an eigenstate as follow. Remember from equation 4.177 that 1 is equal to this. So by using this information we can write that s square is equal to s1 square plus s2 2 square plus 2 s1 s2, that is this. Now let's take it term by term. So the first term would be s1 square parenthesis, that is equal to s1 square upward, that is equal to 3s square divided by 4. So this was the first term. Next we have the second term, s2 2, that is equal to this parenthesis s square parenthesis close, that is equal to 3h square divided by 4. Then we have the third term, that is 2s1 s2, that is equal to 2 sx1 sx2 plus sy1 sy2. I'm running out of space over here, so I'm going to write it over here sc1 sc2, and when we'll solve it we'll get that it is equal to 2h divided by 4 plus negative divided by 4 plus fine. So when we'll simplify it we'll get that it is equal to this. So we have the first, second and third term. Now we have to combine it, and let's look at how it will go about. So by combining the terms we'll get that s square is equal to 3s square divided by 4 plus 3 square divided by 4 plus yes, and when we'll solve it we'll get that it is equal to this. So which is basically s square 2h 1. So now what we have to do, we can show from over here, we can show that s square is equal to 1 negative 1, which is an eigenstate as follows. And remember from equation 4.177 that 1 negative 1 is equal to this. So what we are going to do over here, we are going to show it. So for this we have s square is equal to s1 square plus s2. I'm running out of space over here, so I'm going to write it over here, s2. And now let's take it term by term. So the first term would be 3h square by 4. The second term would be s square is equal to 3a square divided by 4. And the third term will be divided by 2. So now we have to combine the terms. Now let's look at those combined terms. So when we combine the terms, we'll get that it is equal to s square is equal to 3a square divided by 4 plus 3a square divided by 4 plus s square divided by 2 in the down. So when you solve it, you will get that it is equal to this. And this is equal to, which is a square 1 minus 1, that is 2 h square 1 minus 1. So this is